Dear students, so today we will talk about imbalanced classes problem. That what are the imbalanced classes problem and how can we solve it, and what are the related challenges with it. So in this topic, we will talk about confusion matrix. So confusion matrix is a very interesting uh, phenomena in the data mining techniques. So what we have here in this one, we have like four different columns and like four quadrants we have it. So in this one, what we have it like, for example, if the class is yes yes, so it is A. If it is yes no, it is B. If it is no no and yes, this is C. And if it is no and no, this is D. So we have four different probabilities. So here the true positive is called TP, the false negative is considered FN, and false positive is considered FN, and true negative is considered TN. So just to give a simile of the fire alarm, so in case if there is a alarm and fire, so this is yes yes, right? So we call it like yes, there is a fire and there is an alarm. But if there is a fire and there is no alarm, so we call yes no, so this is B. In case if there is no fire and there is an alarm, so we call it as C, right? And if there is no fire and there is no alarm, we call as a D, right? So this is one of the simile what we do it for the understanding this matrix. Okay, now for as a to be more mathematical, what we have it here, we have categorized this A, B, C, and D into TP, FN, FP, and TN, right? So in case we want to find the accuracy of certain algorithm, so how we find it? So usually we do it like in a this way, that for example, if we have A and D, right? So this column we have it, and A and D, so this is A and D over here, right? And the rest of A, B, C, D are divided by this one, right? So by this way we have the accuracy over here. Okay, so we just like exit this drawing mode, right? Okay. And then in the next one we have it, in case for example in this way, if you want to find the accuracy, so what will be the accuracy? So in the diagonal, if you see over here, 0 plus like 990 divided by 1000, so that would be the case of the accuracy in this case. Now in this case accuracy is 99%. Why? Because 0 plus 990 divided by 1000 is 99. And in this one, in this case, case B, what we have it, so here the prediction level is like for finding the accuracy is 50%. Why? Because on the diagonal, if you see over here 10, just like let me highlight this again for you. So here we need to look at the diagonal, right? And here also to the diagonal, right? Okay, and then we find the accuracy, so divided by the total A B C D, right? The total A B C D is 1000. Okay, now if we go to this one, this is also another example for your practice. Okay, now we have what we have here, we have some other formulas, we have it. So for this one, we have precision. So precision is equal to the yes yes, so on both side, on the column and row side, is if yes yes divided by AC. So what is AC? Let me highlight this for you. So this is your AC, the column wise, we call it Amudi or column, right? So this is your AC. Okay, so this divided by this, the AC, right? So that is your precision. What about the recall? So recall is this one, yeah, the same element divided by AB. So AB is horizontal, right? We call it in Arabic ufaqi, right? So this is horizontal. So we have this one, okay. Okay, and then we have another interesting factor which is called F measure. Okay, so F measure is basically the harmonic mean of recall and precision, right? So you can directly put this one like 2RP, this is R and this is P, 2RP divided by R plus P. Or if you simplify the case, if you put the values into this equation, so we will have the defined shape like this one, 2A. So we need this one, 2A. Let me close this one. Okay, so what we need here, we need 2A, from this is 2A, right? So we need to multiply this with the 2, right, and divide it by 2a again, and then b, c except this one. So we need these elements except the d. The d is not included over here, right? So this is how we calculate the F measure. So here are some examples that how we do it, right? So for precision, like if we apply the formulas, like we have here 0.5, recall is 1, F measure is 0.62, and accuracy is 0.99. And similarly for this another example we can also find similarly. And okay, so uh, which of these classified is better? So it depends on precision value, recall value, F measure, and the accuracy of these two different models, and then we see that which is more better. So accuracy wise is equal with respect to f square. The first one is more 0.8, another is 0.08. Recall is same, and precision. So precision wise, the upper model A model is better with respect to the B model. Okay, now we have some formulas over here for your analysis of your algorithm. So this one is already we did it, right? So this is um, error rate is new one. So here you can say 1 minus accuracy. So it's easier. And then we have a positive predictive. This one is precision. We already did this one. Recall we did it. Yeah. So specificity is like Tn. So this is Tn, right? This is your Tn divided by Tn NFP. So this divided by this the lower horizontal. So this formula is a new for you. Okay. And what is FP rate? Okay. False positive rate is the opposite of 1 minus specificity. If you find the specificity, then you will minus it. So mostly the values ranges from 0 to 1, like in the probability, or you can say 0% to 100%, or from 0.1 probability to 1 probability. And then similarly 1 minus sensitivity, you can also have this one. And power is different. So power is if you minus it from 1, so that becomes the power of all algorithm you are having it or you are devising it. So here are some more examples for your practice at home, so you can do this at home, right? Okay, so then the next concept is ROC curve. So we will have this in a next session. Thank you very much for time being. Take care.